dealing with a cylindrical can. So I've drawn my diagram. It says 2.5 litres of liquid, so we've got information about volume. So I've written out volume equation, probably in your formula booklets, or it's just pi r squared is the circle on the top, multiplied by the height for a cylindrical prism, circular prism. We are then asked to determine the dimensions of the can that will minimize the amount of material used in its construction. So the amount of material used will be surface area, so I've written that. Now, because I want to gain things about area from a volume, I need to change my litres to centimetres cubed, because then I can get values for centimetres to work with my surface area. So I set this up now as 2,500 equals pi r squared h, and I'm going to rearrange this to write one of the two unknowns in terms of the other, so I can then put it into my surface area. Now, the simplest for me, I think, is let's replace this h. So I'm going to rewrite it as h is 2,500 over pi r squared. That then can go in over here. So surface area is 2 pi r times 2,500 over pi r squared, and then plus 2 pi r squared. Okay. So let's simplify that. So pi r cancels with pi r squared, leaving just the r. 2 times 2,500 is 5,000. So I've got 5,000 over r plus 2 pi r squared. I'm going to rewrite that just using index, negative index, so 5,000 r to the minus 1 plus 2 pi r squared. Now we are being asked to minimize the amount of material used, so we are going to have to solve the differential equation again. That differential equation will be ds dr equals 0. So first of all, ds dr equals, so we've got minus 5,000 r to the minus 2 plus 4 pi r cubed. Okay, so I need to solve that equaling 0, and I'm going to do that on my calculator. But before that, I've realized I've just made a mistake. So this 2 times 2 should be the 4, but that should not be a 3. That should just be 4 pi r. Sorry for the mistake. So I've put my equation in. I've just rearranged it a bit to put the minus 5,000 r minus 2, but x's instead of r's, that's all. If I graph that, see what comes up. And it looks like nothing's coming up. Now that is going to be not because nothing's working, but because my window settings are going to be wrong. So we go to window and let's change something. So probably let's try and find it. We don't need to go below 0 for x, because that would be not a cylinder, but we can maybe go up to 10 for r. And let's try, well, the volume, just give something a go. Let's try the 5,000. Let's see whether that does, what that does. Okay, so you can see some just creeping in, so I went far, far too high. So let's go all the way back down again, actually. Let's just go to the 100. It was just the x that we needed, but we found through trial and error. Okay, so it's drawn. So now we can see this is the point I'm after for my r value. So I'm going to calculate 0. Again, the left of it, I think, based on that 4 point, I think I'm already to the left of it. Let's just there we go. Look. Come back into the picture. I'm left of it. Let's go up. Right of it. And just go near it. Press guess, enter. And I get an answer of 7.355. So we think R is 7.355 centimeters. So let's just go and check our question. Determine dimensions. So we've got R, but we need to know height. Now height, okay, so H is 2,500 over pi times 7.355 squared. So if we work that out, so I've got 2,500 over pi times 7.35 squared. Press enter and I get 14.71. So 14.71 centimeters. Obviously take note of rounding if you're asked to 3 significant figures or how many decimal places. I've been inconsistent. I've got 4 significant figures, but you'd probably be asked for 3. Okay, so finally, just final check, dimensions the can that will minimize the amount of material. Okay, so I found R of 7.355 centimeters makes sense, and therefore the height being 14, that would use a surface area, we think, of the minimum amount of material used to give that volume of 2,500 centimeter cubed. Okay.